Hi guys, Ms. Griffin again. We're looking at Unit 10 Skill 1B. So it's an extension of 1A. We're now going to learn about different properties and theorems that can be used to find angles and arcs in a circle. So the first property or theorem is about parallel chords. Remember, chords go from one point on the circle to another point. And we're talking about these ones that are parallel to one another. So if two parallel lines intersect a circle, meaning if those chords are parallel, then the intercepted arcs are equal. So you know that the distance between parallel lines is always equal. That distance is the same as this distance, which is the same as this distance. So what we're saying is that the distance between these parallel chords here and here, in terms of the arcs, are now congruent. So we're going to do a quick example based on property 1. If we know that arc AB is 100, and we know that these two are parallel, now it would be given that they're parallel. I forgot to write it on there in the actual text, but it would be like that on a test. And it says find the angle BDC. So I'm going to call this as X. I'm going to first notice that this is a diameter because it's going through the center of the circle. So this arc out here is 180, and then also this whole arc is 180. So I'm going to do a little bit of math and recall that now that these chords are parallel, the arcs between them that were intercepted are congruent. So I'm going to do 180 take away 100, and that gives me 80. But then I know that 80 has to be split up evenly into two parts to get those two equal arcs, so 40 and 40. And of course my goal here is to find this angle X. X is an inscribed angle, so taking you back to the last skill, inscribed angle you have to divide by 2 to go inside. So X equals 40 over 2, which means that the measure of angle BDC equals 20 degrees. Okay. The next one we've got is a theorem or a property about a right angle. So it says the intercepted arc for an inscribed angle in a semicircle is 180 degrees. So let's see what that's talking about. Here's an inscribed angle, and it's intercepting this semicircle, because again, this is going through the center. So this arc out here, they're saying is 180 degrees. Therefore, to go find my angle, I have to divide it by 2. Well, 180 divided by 2 is 90. And so then this angle will always be a right angle as long as it opens up to a diameter or to a semicircle. Another property we have is about a tangent meeting a chord. So remember that a tangent touches one time, crosses, circle, one time. So BC is our tangent, and then we have chord AB. This angle that is formed is inscribed. It's on the edge of the circle. And so therefore, when it opens up to arc BA, as weird as that looks, that 120 has to get cut in half to find the angle. So 120 divided by 2 gives us 60, so therefore in this picture X equals 60. The same sort of thing applies when we have a tangent that meets a radius or a diameter. So here's the tangent, here's the radius. If I want, I can extend it to make a diameter. And if I do that, you'll notice that this arc that it intercepts is 180 degrees. So therefore, to find the angle, I cut it in half, and that means that a tangent is always perpendicular to a radius or a diameter. Flip it over, we're going to see a couple more examples. So we got one more property, and then we'll see an example based on those last 3 properties. Inscribed angles that intercept the same arc are congruent. So we're saying if I have this inscribed angle X, it opens to arc WZ. So angle X opens to WZ, the arc. And angle angle Y opens to, well, it opens up to WZ again. So if these two angles open to the same arc, then angle X must be congruent to angle Y. And you can see this with numbers. If I tell you that this arc was 100, I cut it in half to find the angle, and I find 50. If I cut it in half to find this angle, I find 50. right? So the same thing can also be said, I don't know if you can see it here, but the same thing can be said about angle W and angle Z, because both of those open up to arc XY. All right, so now we've got this example that says we've got a diagram where the diameter is drawn, BD, CDE is a tangent, and DA and BA are chords, and the measure of arc AD is 112. So this arc right here, A to D, is 112. Find the following. BDC. Okay, so here's BDC. It's a tangent meeting a diameter. Some of you might know it automatically, others might need to think about it for a second. So that angle BDC opens up to this arc BD formed out of a diameter. So this is 180 degrees right here. And so what I need to do is cut it in half to find that this is going to be 90. The next one I need to find is angle DAB. D to A to B, and it opens up again to this semicircle. So I'm going to divide by 2 because it's an inscribed angle, and I find out that that's 90 degrees. So those are the two special properties we talked about. A right angle in a semicircle is always formed when it's inscribed, and a tangent is always perpendicular to a diameter or to a radius, forming right angles. So the next one we might have to work at for a second. It says find angle ADE. So let me outline that in a different color. Colors are super helpful when you're doing these problems, by the way. So ADE opens up to this blue arc right here that I'm now outlining in orange. ADE opens up to this arc. And it's on the edge of the circle, so that means I'm going to take 112, cut it in half. 112 cut in half is 56. So I'm going to put my 56 right there. Then the last one that we need to find is angle BDA. B to D to A. So it's this pink one right here. You've got a couple options for finding this. You could find this arc, then cut in half, or you could just use the fact that angles on a line equal 180. Goodness, I almost said 360. So I've got 180, take away the 90, take away the 56. And that leaves me with 34. Okay? And the last and final property is a little weird, but it's not so bad once we get used to it. So it says opposite angles in a quadrilateral inscribed in a circle sum to 180. So before we get there, let me just tell you that I'm going to give you an example where we call this as angle X and this is angle Y. Okay, because they're opposites of one another, right? So if this is angle Y right here, BAD, and it opens up to this arc right here, then I'd have to multiply to get 2Y for the arc's measure, because inscribed angle is half of the arc. Same idea with angle X opens up to this arc over here, BAD, multiply by 2, and it gives me 2X. So what we're saying is that 2X plus 2Y equals 360, right? Full circle. And so really this is like 2 times X plus Y, because there's a 2 in common with both of them. If I want to know what just X and Y make in total, I can divide by 2. So this gives me X plus Y equals 180. So this is where the rule comes from, but all you have to memorize is that these two together, opposite angles in a quadrilateral, inscribed in a circle. It's very specific. In a quadrilateral, inscribed in a circle, equal out to 180. So this is angle C plus angle A equals 180, and really I should be putting measure of. And the same thing can be said about angle B and D. Measure of angle B plus measure of angle D equals 180. So now we've got a quick example. It says that we've got this quadrilateral inscribed in a circle. So those are the 3 key words, quadrilateral inscribed in a circle. What's the measure of angle ADC? So here's my X. I could do the work and say, okay, this angle opens up here, that's 2X because I double it. This angle of 72 opens here, so I double it, 144. And then 2X and 144 make 360, yada, yada, yada. Or guess what? If I can slowly erase all of this, my trick tells me that, whoa, I'm erasing too much now. My trick tells me that these two opposite angles inscribed in this quadrilateral add up to 180. Okay, so subtract and we get x equals 108. So measure of angle ADC equals 108. All right, I know we just threw a lot of properties at you, but I promise you that they're not hard. They're just an extension of what you learned last class, more inscribed angles. And so now you should go practice. Sounds like a cheerleading cheer. Go practice. Go practice. Just kidding. All right, have fun, good luck, and let us know if you have questions.